exercise 5A, I'll just do the first 3 parts of this because it's the same situation each time. We've got a force coming down here of 5G. So my normal reaction coming straight up here, the reaction force here, that's also 5G. And that means that the maximum friction that we can have is equal to mu times by r. Now mu, they tell us in the question earlier, is 1/7. The reaction here is 5G. And so the maximum that can be is 1/7 of 5G, which tapping into the calculator tells us it's equal to 7. So the maximum friction we can have here is 7. Well, actually, it's only being dragged forward that way with the force of 3 newtons. And so for the friction here at this case is just 3 newtons, and it stays still. This one here, the force has now increased all the way to 7 newtons. So you've got 7 newtons pulling it that way, and we've got a friction force that's actually now at its maximum of 7 newtons. So it's still, again, it's stationary. It's not going to move because those forces are still balanced, but a tiny bit more now, and now we're going, looking at this direction here, we're going 12 newtons one way. Our frictional force will now be 7 back again. And so the resultant force will be 5 newtons to the right. Using F equals ma, 5 equals mass times acceleration. So the acceleration here will be going 1 meters per second off to the right hand side. Now, the friction force here was 3, here was 7, and here it stays at its maximum point of 7.